To continue with our lecture on variation, today we will talk about the inverse variation. Though I've already done an introductory aspect to this topic before in one of our previous classes, but in this class we will delve deeper into the concept of inverse variation. All right. Now let us consider if we have two quantities, for instance, right, and we realize that one quantity increases as the other quantity decreases, then we can say that the first quantity is inversely proportional to the second quantity. And this could be seen the other way around also. So if this quantity A, let's consider quantity A, if as quantity A increases, if we observe that quantity B decreases, then we say that A is inversely proportional to B. And this is how we denote the inverse proportionality equation or expression, as the case may be. All right. So this is how we denote it. And the other way around, we could say that if A decreases and B is seen to increase, then it also shows the inverse relation or the inverse variation. Is that okay? So this is how we denote it mathematically. So for instance, let us say that quantity Y varies inversely as X, or if Y is inversely proportional to X, we say that this is how we can write it mathematically. Okay, and just like we did in the direct variation, we would have to introduce the equality sign so that we can find the values of X and Y. And to introduce the equality sign also means that we are going to introduce the proportionality constant. Of course, the proportionality constant that we use often here is K. Okay, so to do that, Y will be equal to K over X. And if we decide to cross multiply so as to obtain a linear equation, we have K will be equal to YX. So this equation is what we use to relate the first quantity or the first variable, which is Y, to the second variable, which is X. Is that okay? And this is gotten, or this is derived by substituting the value of K into our initial equation or initial expression. Okay, now having said that, we would like to solve some problems so as to know how we can apply these principles. Okay, the question is, given that Y varies inversely as the square of X, we're told that Y varies inversely as the square of X. That is the relationship. Of course, we are going to remove this variation sign and then introduce the proportionality sign. So if we have that, we have that Y is equal to K over X squared. And I said we'd have to make K the subject of the formula, or to obtain the value of K. So to do that, we would have to cross multiply, and in cross multiplying, we have K to be equal to YX squared. But in the question, we were told Y is equal to 8 and X is equal to 2. So when Y is equal to 8, when Y is equal to 8 and X is equal to 2, we have K to be equal to YX squared, which is 8 times 2 squared. Of course, 8 times 2 squared is still the same thing as 8 times 4, which is 32. Now, since we have the value of K already, the next thing is to input it or insert it into this particular equation over here. Let me show you the equation. We are going to substitute the value of K into Y equals K over X squared. So if we do that, we would have Y to be equal to K over X squared. This gives us y equals 32 over x squared. All right, this is the relationship that connects x and y together. And from the question, we were told that we should find the equation connecting x and y. And of course, we have done that. This is the equation connecting x and y. All right. So to solve for that, I said, hence, find the value of y when x is equal to 6. When x is equal to 6, all right, what is y? Y will be equal to 32 over 6 squared, which is equal to 32 over 36. And if we divide through by 4, because 4 can go in both terms, okay? So this divided by 4 gives 8, and this divided by 4 gives 9. So we have the final answer to be equal to 8 over 9. All right, this is the first case. The second case is, we said, find x when y equals 1 over 2. So when y equals 1 over 2, what is x? So y, which is equal to 1 over 2, 32 over x squared. All right, and if we decide to make x squared the subject of formula, x squared will be equal to 32 over 1 over 2. And remember, 32 over 1 over 2 is still the same thing as 32 times 2 over 1, because this will go up while the other one will come down. Okay, so we'll have this to be equal to 64. Of course, x squared is equal to 64. We're asked to find the value of x, not x squared. So x will be equal to the square root of 64, which will be equal to 8. 8 is our final answer. So when x is equal to 6, y is equal to 8 over 9. And when y is equal to 1 over 2, x is equal to 8. This is where we'll draw the curtain for today's class. If you have questions for me, you can drop them in the chat or in the comment section on the platform, as I will be there to attend to all your worries. See you in our next class, where we will discuss the other type of variation, which is the joint variation. Bye for now.